Hello everyone, good day. You are welcome back to Awesome Arithmetic Academy. Today, the topic we are having here is mapping and function, and by God's grace, we are going to be talking about it based on the scheme I released the other time. Those are the things we are going to be looking onto in this topic. So, let's start with the definition as it was written. Mapping and function. You have talked about set, and we know what a set is. Set is collection of what elements that are well defined. That is, there will be something that is bringing two sets together before we can say they are well defined. And in that case, mapping function they are also from a set. So now, when we see mapping, in this case, we can say that when we have two non-empty sets, we have two non-empty sets. If there is a rule which assigns an element in one of the sets to the other to another element in the other sets, then we say the relation is a mapping. So what we are saying here is that, let's say for instance, I'm having two non-empty sets. Two non-empty sets. Let's say the non-empty sets are A and B. Then there is an element from A, let's say small letter A, whereby a rule is given that makes this element of A, let's say the rule is F now, is now making this element A to be assigned to a unique element of B. Let's say the element in B was small letter b. So when you have something like this, that means we say it's a mapping. And mapping is represented whereby you have f of A maps to B, or you write it as A maps to B. So now an element of A is mapping to B with a given rule. So this F is standing as a rule. So now sometimes you can call this element of A, all the elements under it as the input, that when I put any value here into the rule given to me, it will produce an element of B. So that's why it is called mapping. So element of A, let's say set A is known as the domain. Set A are called the domain, while set B are the codomain. So another thing we need to understand here is that any elements of the codomain which is assigned to an element of the domain is called an image. So this is telling us that under this element of A, all the elements of A must have a unique element in B, but not all elements of B must be having an element from set A. So in that case, any of the elements B that is having an element from the domain is going to be an image, and the set of images are known as the range. So that is all the elements under V now that are having an element in A are going to be called range. So in that case now, how can we know if a relation is mapping or not? We have two most important uh, things to note. The first one is that all the elements of this Mr. A, all the elements must have a unique element of B, must have a unique element in B. That is, all the elements must be assigned to an element of B. Why? The second one is that none of the elements of A will be having more than one image. So that's why we call it a unique image. So for instance now, you're going to be looking at example of mapping now. Let's say for instance I have set E, which is mapping to B with a given one. Let's say I have A, B, and C at this side, and then this side is X, Y, Z. So when can we say A? When can we say this function, this mapping, this relation is a mapping? It's when all the elements A, B, C are having elements here. They are assigned to an element here, and none of these elements is having more than one element of the domain and codomain. For instance, if I have something like this, I can see that set A maps to Y, sorry, element A is to Y, element B is to Z, and then element C is to X. None of all the elements here are having, they are having what, an element at the codomain, and the other thing is that none of the elements here is what assigned to two images here. So in that case, this is a mapping. This is a mapping. So we can say this is a mapping. Okay, let's look at another example. Let's call this one example 1. Example 2 now, let's say an element X maps to Y. We have P, Q, and then at this side, we have W, X, Y, and Z. So, if this map to this, and this map to this, if they ask us that is this a mapping, is it a yes or a no? It is a yes, because the property we're given is that all the elements here must be having a unique element at the codomain, and it is shown here that P is mapped to Y and Q is mapped to W. We are not concerned with those ones that are not having any, that are not assigned to any element of the domain at the codomain side. That one is not as important, because this side is the codomain, and then an example you can use to understand this is that take this side as children and this side as men. So it is possible that what? It is important and it is very sure that all children must have what? A pair, they must have a father, that is P to Y, that is Y is the father of P, Q to W, that is what? W is the father of Q. But it's possible for men not to have children. So that's why it is possible this way that what X and Z not having any element here means they are just men who are here to give birth. So in that case, it is still a mapping. So it is still a what? Mapping. It is a mapping. So for you to write this one now, you can just write f of p. P was assigned to what? Y. So that's how you write it. And then f of q was assigned to w. So in that case, you've answered the question. So now let's check this one if it is also a mapping. Yes, so we have W and Z. In this way, you can see it this way as well. Let's say we have A, B, and C here, and this side is X, Y. So if I have something like this, when they ask me if this is a mapping or not, this is actually a mapping. Why? Because all the elements here are having an element on this side. And the other one is what? That's what? None of these elements is having two elements at the what? It's attached to two elements at the codomain. So in that case, this is a mapping. Whether this is having two or not doesn't mean. Remember, I told you just take this side as men. So it's possible for a man to give birth to more than one child. So that's why A and C they are just like children for element X, and then B is the child for element Y. So in that case, it is still a mapping. I hope that is understood. Now, I just want you guys to give me the answers to this under the comment section. You answer these questions. Number 4. And drop your try this and drop your answer in the comment section. Thank you. Bye. Hi, welcome back. Now, in the last class, we talked about mapping. Here today, we are going to be talking about function. Function. The only difference between a function and a mapping is that function is when all the elements at the codomain are numbers now. They are no more letters. So in that case, we call it a function. Mapping and function are almost the same. The only difference between the mapping and the function is that the elements at the codomain for a function are numbers. I hope that's okay. And in that case, we are going to be looking at some things here to see how it works. So now, I can just say this is a mapping whereby all the elements of the codomain are numbers. And that's all. So in that case, once you've said that, you are done with the definition for function. So now let's look at some examples. When we have something of this nature now, we have f being a function which maps set A to B, and then I have it here as 2, 4, and 6. Let's say in this case, I'm having 36, 4, and then 16. Let's say in this case now, this is mapped to this, 4 is mapped to 16, and 2 is mapped to 4. So in this case, since this codomain are numbers, that means that this is a function, it is no more a mapping. And then for you to say this now, there is one particular function, or sorry, there is one particular rule that is making 2 to be assigned to 4, 4 to be assigned to 16, and 6 to be assigned to 36, right? So in that case, that's what we're actually doing here, and that's why we call it mapping by what. There must be a group which is making an element here to be assigned to another here. So in that case, an example that you can give is that what? Or let's try and solve this, that what will make 2 to turn to 4, 4 to 16, and 6 to 36. If you think very well, you see that what? When I square 2, I will get 4. When I square 4, I will get 16. And when I square 6, I will get 36. So in that case, our function can be what? Given that f of x is x squared. That is when my x is 2. That is when I put 2 now. You know, we call this side as the input, and then this is the output we are going to be having. When I plug 2 for x here, this will turn to 2 squared, which will now give me 4. When I plug 4 here, this will give me 16. And when I plug 6 here, it will give me 36. I hope that's understood. And that's what function is talking about. So now, so for this one now, this is the rule assigning this to this. Now let's move on to the types of mapping. As we said that we have the one-to-one and the onto mapping. One-to-one is saying that what? When all the elements at the domain, it is a mapping whereby all the elements at the domain are having what? Unique elements at the codomain, and all the images of the codomain are distinct elements of the domain. I hope that's understood. That is, for instance, this one like this, it is one-to-one. The reason is because we already know that it's a mapping, so that's all. Then the second reason is that all the elements here are not attached to more than one element at the domain. So in that case, it is one-to-one. It is one-to-one. So now, one-to-one. So what do you say about one-to-one is that what? When all the elements of the domain are assigned to different and unique elements of the codomain. This mapping is said to be one-to-one. So now, all the elements at the domain are having distinct and unique elements at the codomain. So in that case, we call it a distinct. We call it a one-to-one mapping. Example is that all the governors in Nigeria they are assigned to different states. All the governors are assigned to different states. There is no governor that is ruling two states, and there is no two states that is what? There is no governor that is ruling two different states, and there is no two governors ruling one state. So in that case, we call that one-to-one mapping. That's just a very good example. That's just a very good example to be used, or we use the state and capital that all the states in Nigeria are having different capitals. All the states in Nigeria are having different capitals, and what? None of the capitals is being what? None of the capital is being a city of two different states. So in that case, we call it one-to-one. You can use the governor of state, even the what? Vice chancellors of different universities. They are what? With respect to the university they are holding, that is another example of one-to-one mapping. And in that case, you can just use any of this example to solve it. So what's now the difference between this and the onto mapping? Onto mapping is the what? When all the elements of the codomain are images of the elements of the domain. So what is this one saying is that what? All the elements of the codomain now, they are having elements. They are images of elements at the what codomain. In this case, the images, that is images which is the range, is not going to be equal to what? The codomain. That is, you can just say, therefore, the range, which implies that the range equals to the what? Codomain. That is the range, that is set of numbers, set of elements of the range, and set of elements of the codomain are equal. So in that case, we call it an onto mapping. So let's give an example to see what we are saying under this one-to-one and onto mapping. So let's say, for instance, if I have, let me use another letter now, x mapped to y, I have a, b, c, d here, and then I have x, y, z here. So in this case, if I have something like this, okay, let me clean this. So now, when you're being asked that, is this a one-to-one or onto mapping? What are you going to say? Okay, anyone you say is correct. It is one-to-one, at the same time it is onto. The reason it is one-to-one is because all the elements here are having different image. They are having different images at the codomain. So that's why it is one-to-one. Then why is it onto? It is onto because all the elements of the codomain are images of elements at the domain. So in that case, it is onto. So now it is what? One-to-one and onto mapping at the same time. So let's check this one now. If H is a mapping that maps A to B, and then I have set A, B. I have A and B, and then this side I'm having C, D, and E, where B is mapped to C and A is mapped to D. Is this a one-to-one or onto? This is one-to-one. The reason it is one-to-one is because the two elements here are having different elements at the what? Codomain. That's just the main reason. Different elements. And the reason it is not onto is because not all the elements here are images of elements here. So it is only 1 to 1. 1 to 1. So now let's look at the third example, which will be the last one to explain this. Okay, when I have a function f which was assigned an element of x to an element in z, where the elements under x are a, x, z, an element under y are b and c. So if z map to c, x map to b, and a map to c, is this a mapping? Yes, because none of the elements here is attached to two elements here. And then is it now 1 to 1 or onto? It is onto. The reason is because of what? The elements at the domain are not having different elements at the codomain. And then the reason it is now onto is because all the elements here are what? Images of elements at the domain. So in that case, we say it is what? Onto mapping. So now, if you actually understand this, I want you to provide answer to this one. If the function h maps an element it sets w to set y, whereby set w is having 1, 2, 3, 4, and set y is having 3, 2, 1. So tell us whether this is 1 to 1 or onto. After you've answered that, tell us why it is 1 to 1 or why it is onto. Have an awesome day. Bye. Hi, welcome back. Today we are going to be solving some example under mapping and function now. The first example says determine the domain D of the mapping f of x, which is what? The function is 2x plus 3. If c equals to 3, c is a set which is having elements 3, 1, and 5, and this set is the range of the function which is defined on D. The second question is the same thing. Anything you are doing in the first one is what you are going to be applying in the second one as well. So in that case, I want you guys to try the second one, whereby I will provide the solution to this one. So when you look at this question very well, it says domain D. And if you remember when I was explaining to us that function, we say if this is the what? Rule, the rule that is mapping an element in the domain to what? Give us an output in the code domain. So this is just what we are having, which means that these ones are what gives us this element, yes, once we put a value for x. In that case, what does that mean? It means that what? You are looking for the value of x. You are looking for the value of x. You are looking for the value of x. So in that case, what are you going to do? Solution. You are given f of x to map to 2x plus 3. So now the first one is what? when the range is 3. So this implies that what we like to do, we have this one 2x plus 3 to give me 3 because I'm looking for the value of x. I hope that's okay. So now in that case, when I do that, this will give me what? 2x. Collecting the like times 3, we go to the other side, which will give me what? 3 minus 3. And in that case, I will have 2x to be equals to what? 0. So looking by the value of x, we divide both sides by 2, and x will give me 0 divided by 2 is 0. So that means the first domain is 0. Then the second one, when the range is, well, the second argument was 1. So in that case, what will I have? This implies that 2x plus 3 equals to 1. And when I solve, that will be 2x equals to 1 minus 3. And that will be 2x equals to minus 2. So in that case, dividing both sides by 2 will make us to have x equals to minus 1. I hope that's clear. And the last one, when the range is, the third value is what? 5. So I will still put it here, which remains that what? 2x plus 3 equals to 5. When I collect the left hand, 3 is going to the back, that will be 2x equals to what? 5 minus 3 is 2. And dividing both sides will make x to be equals to 1. So in that case now, the domain is what? Therefore, a domain equals to 0, minus 1, and 1. 0, minus 1, and 1. And that will be all for now. I want you guys to try and provide solution to this second one here. Have an awesome day. Bye. Okay, welcome back. Today we are going to be talking about the two spatial mapping, which is part of the subtopic in the state. So we have the identity mapping. So identity mapping is telling us that when all the elements at the domain are assigned to the same kind of element at the codomain, that is identity mapping. For instance, if I have something like this, if A maps to B, and then I have A, B, C here, and then B, C, A at this side, whereby C is mapping to C, B is mapping to B, A is mapping to A. So in this case, we call this an identity mapping because A is mapping to the same thing here. Identity, there is no any change there. It's just like you providing the function that f of x is x. That's just the name. If x is 1 here, I'll still be having 1 here. If x is 2 here, I'll still be having 2 here. So that is what we refer to as identity mapping. And that's just what identity mapping is talking about. I I hope that's clear enough. Then the second one, which is the what? Constant mapping. Constant mapping. Constant mapping is a mapping whereby all the elements at the domain now are being assigned to the same image at the codomain. To the same image at the codomain. So what does that mean? If I have set x mapping to y, whereby it says x is having a, b, c, and set y is x, y, z. But through my mapping, I got A to be z, b is also z, and c is z. So I'm having only one image. So when I'm having just one image and all the elements at the domain are being assigned to that image, in that case, that image, that kind of mapping is a constant mapping. And a little example is when you are having, if I have for instance, f of x is what? Let's say 2x squared plus 3. And then it's actually find f of minus 1 and f of 1. And this actually puts 1 and minus 1 for x here. What am I going to have? Let's see. If I put minus 1 here, that will be 2 brackets minus 1 squared plus 3. Minus 1 squared will give me 1. 2 times 1, 2 plus 3. That's what? 5. And when I put 1, 2 brackets 1 squared plus 3. 1 squared is 1, 2 times 1, 2 plus 3, 5. You see that if I'm to draw the mapping of this, I'll be having minus 1 and 1, which are mapped to what? 5. So in that case, we call this a what? Constant mapping. I hope I've explained something to us today. Please don't forget to like, share, and comment. If you haven't followed us as well, try and follow and also subscribe to our YouTube channel at Awesome Arithmetic Academy. Have an awesome day. Thank you. Bye.